I forgot to do this first. Apologize. I'm Shannon. I'm the curator here at the Cosmosphere. I have a background in my bachelor's is in history. I'm not used to this thing either. Oh, there we go. I got it. My bachelor's is in history. My master's is in public history, sort of. We'll say that. One of the things how I describe public history is it's the history of how we remember things, which is a very romantic way of describing what I actually went through in grad school. But nonetheless, the way we remember things changes over time. Historians will argue about it, blah, blah, blah. But today, we are going to talk about the rover. I like to start at this beginning part with the who, what, when, where, why. So who built the rover? I mean, you think NASA, sort of, but Boeing was the contractor who built the rover. GM helped, especially with the tires, which we'll get into later. Also, another who is it was driven by astronauts. Where? On the moon. It was a battery-powered four-wheeled rover used on the moon during the last 3 Apollo missions. So that's Apollo 15, 16, and 17. The development began even before we landed on the moon. NASA was having conversations about the rover as early as 1964, and you could even argue a little earlier than that. But astronauts weren't actually driving it on the moon until 1971 through 72. And then the why. What is the glory of the rover? The rover is awesome because when we talk about the early manned space program in America, it's often tinged with that Cold War competition with the Soviet Union, which was a huge part of our manned spaceflight program. But the rover was designed with science in mind. So we were almost coming out of that Cold War mentality, and now we just want to know about the moon, about the geology of the moon, about everything about the moon that we can find out using our rover. And they were able to bring back a lot of samples, which we're still learning from today. So what did the rover have to do to survive? It had to withstand temperatures from minus 250 Fahrenheit to 250 Fahrenheit. So not just extreme temperatures on one side, but extreme temperatures on both sides. It had to drive through clingy, abrasive dust without its mechanism seizing up. It had to climb high slopes. It had to fit 2 astronauts in their giant suits. I would say comfortably, but NASA wasn't really worried about their comfort necessarily, but you got to stay on the rover, keeping in mind that the moon has 1/6 gravity. So very low gravity compared to Earth. This is just a slide to show you guys what was on the rover. The antennas were how they spoke to mission control. The TV camera was used to record early lunar activity. It was even used to record how they unpacked the rover from the LEM. And once it was mounted on the rover, it could transmit footage directly to Earth via the Lunar Communications Relay Unit. The TV camera could even be controlled by people on Earth. So mission control could control it, and that's why we have the footage of them taking off from the moon, the ascent stage leaving. That was cool, thank you. Yes, I thought that was awesome too. As I mentioned, the designing of this began before we even landed on the moon. So one of the things I read was it takes a certain amount of hubris to design a vehicle for a place we've never been, which I think is fairly accurate when you start talking about what we need. We don't know. But I say that to dramatize the story. Really, we had been to the moon a little bit beforehand, just not manned, unmanned. So Pioneer 4 was the first US spacecraft to leave Earth orbit, and that was in March of 1959. So it didn't get to the moon yet. I know what you're thinking. If only there was somewhere I could see the Pioneer 4 payload. There is. You can see it here. And unfortunately, this is not the only shameless plug I'm going to do. Ranger 7 was the first American spacecraft to take images of the moon. So it didn't, I mean, it crashed on the moon, it didn't land, but it was taking images of the moon for us. And the first questions that NASA received after these amazing images were made public was, is it solid enough for humans to land on? So from the very beginning, it was always about the manned missions. And NASA said, probably, at least in the part we saw. So here's the, let me look at this, the first image taken by Ranger 7. We're lucky we have people who understand these types of images. But the biggie for learning about the lunar surface prior to man actually landing on it was Surveyor. Surveyor was an unmanned spacecraft that actually soft landed on the moon. We sent 7, only 5 landed, only 5. 5 landed. This was between 1966 and 1968. So obviously everyone is watching this to learn more about how we're actually going to get astronauts on the moon. And then later, how is our rover going to drive through it? What kind of soils is it going to have to get through? So Surveyor proved that the surface was solid enough for a manned landing. It sent literally tens of thousands of pictures, just the first one. It had a scoop and it would dig trenches. It would manipulate the surface material in front of the camera that was on Surveyor so we could get an idea. One of the later ones even performed a hop maneuver that showed how the movement of the Surveyor affected the surface soil. And also rocket engines took off or ignited from the Surveyor to show how that affected the surface too. Because when our astronauts leave, they're going to ignite a rocket engine. If only there was some place you could see a Surveyor. We've got one right here. Actually, it's right across from our planetarium. It's on this floor. Check it out. It is on loan to us from the Smithsonian. Oh, I didn't even talk about the scoop. So another exciting thing that came out of the Surveyor program was that Apollo 12, the Surveyor spacecraft were landing in places that NASA was considering for a manned landing. So one of the place that Surveyor 3 landed, Apollo 12 actually landed near there and recovered the scoop from it. And I think a camera. We don't have the camera though, but recovered a couple things from it so we could see how the moon's surface had affected the craft over time. Now, if only there was some place you could see that scoop, which is in our museum, which Reno County residents get into for free, I might add. And that was, I'm sorry, that recovery was in November of 1969 when Apollo 12 actually went. So I don't have a space history background, right? We talked about this. So one of the coolest things I think about the space program is that they were kind of making it up as they went along, which I think is pretty cool. So as I always say, there were no bad ideas in the beginning, right? At first. No, this wasn't necessarily a bad idea. This is von Braun on the Bendix model of the lunar rover. This did not come to being, obviously, because you all know what the lunar rover looks like. There were so many problems, so many challenges that they faced, such as the size, how much it weighed. Many things had to be met before it could go, and this obviously didn't make the cut. It was way too big. There was some talk in the early days that they would send a second rocket with a mobile lab, and then it became a second rocket with our rover, and then finally it was, we'll just shove the lunar rover into the LEM, but we'll get to that later. So anyway, this is just one of the ideas they came up with. Here's another idea. Remember, there were no bad ideas. Hermann Oberth, this is from his book. And there's a couple other interesting ideas. But I want to point out that these ideas came from legitimate scientists, and these were people who were prominent in their field of geology and NASA, respected their opinions. So as I said, there were no bad ideas. So some of these are funny. I don't have any pictures of the hovercraft, of the lunar worm, of the lunar leaper, AKA the pogo stick, the lunar flying unit, which was a rocket powered rover, which thankfully everyone nixed pretty early because it's dangerous to drive on the moon. And then also the one that was considered for a little bit, but thankfully also they got rid of, was the jetpack. It became a huge safety concern. There's only enough weight for one jetpack. Well, what if the guy in the jetpack gets too far and the other guy can't get to him? And there were a lot of safety issues, not to mention, I think you had to wear special pants so you didn't get burned up. I mean, there were a lot of issues, but everything was on the table in the beginning. And then I would like to mention one thing that actually did go, that it did a lot of the things that the rover wound up doing, but not as great. This is the mobile equipment transporter. The astronauts called it the lunar rickshaw. It had 2 wheels and a handle in front. It was only sent on Apollo 14. Alan Shepard and Edgar Mitchell were not very impressed by it. I think the term they used was, it was adequate. A lot of times, I mean, this is supposed to be, they can carry their experiments on it, they can carry their tools on it. I think it was even also, it could be a portable desk. I don't know what they would be writing. I'm sure you need a desk for lots of things. But a lot of times it would get stuck and one of them would have to carry it. They had to take turns pulling it, they had to pick it up. And one thing that you don't necessarily think of right away is that they're in their spacesuits while they're doing this. So there's a lot of physical exertion going on. And when you're physically exerted, you're using more oxygen, you're sweating, the perspiration. So they were actually using a lot more of their resources that were in their backpacks. So their moonwalk couldn't be as long because you need to get back. And I'm sure Mission Control told them a billion times. I don't have the numbers with me. I forgot to write them down, but they were walking. This was their last, their last time out on the moon. They were trying to get to a certain point. They kept getting lost or thinking they were further along than they were. And then finally they called it off. And it turns out they were like, I don't remember, 60 feet from where they wanted to go. So anyway, but I don't want to act like this wasn't a good thing. They brought back some really cool samples that they would not have been able to carry. So I'm not trying to say it was the worst thing on Earth. It just wasn't that great. They didn't send it again, let me say that. If only there was some place where you could see this mobile equipment transporter. It's down in our Apollo gallery. Reno County residents get them for free. So anyway, moving on. So let's talk about the development of the rover as we know it. There was some discussion, as I said in the beginning, about creating a pressurized vehicle. So they would sit in there without their spacesuits on and do science and move around on the moon. Finally, NASA officially expressed interest in an unpressurized moon jeep in 1964. So with this unpressurized version, you have to wear your spacesuit, right? So luckily, the Apollo 15, 16, and 17 were part of what they called the J missions. So it was a beefed up spacesuit. They actually changed the waist joint in the suit so that they could ride on the rover more comfortably. There was some changes to the service module too. I won't get into that, but they had better backpacks called a Bliss. They had a better backpack so they could stay on the surface longer. So there were lots of cool things that were going on that were in the name of moon science. Lunar science, we don't have an educator here. Okay, we're going to call it moon science. I'm sure they would correct me on that. As I mentioned, there were several competitors. Boeing won out, GM helped. Simplicity was the key. One of the quotes I read said, "The parts that are left off will never break." That's true. It was meant to withstand high temperatures, solar radiation, micrometeoroids, all in an airless vacuum. It could carry 2 times its weight. It could climb really high slopes. And it could track itself. It had a navigation system so that the astronauts always knew where they were and the fastest route back to the limb. So the book I read, the Across the Airless Wilds, one of the comparisons that I thought was very good was that think of Apollo 14, Alan Shepard and Edgar Mitchell huffing and puffing, trying to get samples, whereas the Apollo 15 team, it's not, I don't want to act like it was a leisurely drive, but they're not using as many of their resources. They're more comfortable. They're able to, in essence, do more science. No educators here, so I'm going to say it like that. Collect more samples. One of the things that was common in all of the space program was the redundancies. So this had, let me look, 4 motors, but it could run on 3. If 2 failed, it could run on 2. And if 3 failed, it might be able to limp back on 1. Now, of course, the astronauts were not allowed to go any further than they could walk back as a safety issue. Nonetheless, I don't want to walk 6 miles on the moon. And this is kind of funny. The contract was signed and the rover was delivered in 17 months, which was unheard of in the space program. It was vastly over budget. The contract had it at 19 million and the actual cost was 38. The tires, I won't get into as much. They were revolutionary, don't get me wrong. They were a woven mesh of zinc coated piano wire and they had titanium chevrons on them, which I'll point out later to keep them from sinking. They're my captive audience and they're stuck with me, so I'm going to go off on a tangent here. One of the guys who helped develop the tire started out post-World War II, I think in Poland. He was working on tanks and a lot of the mud and the issues they had getting their tanks through during the war. He had this excellent phrase, I should have wrote it down, but basically the tire you need is dependent on the surface it needs to drive on, which makes complete and total sense. Someone just had to say it out loud. So from the very beginning, the thought was we need as much information about the surface and we also need to test as many things. I think they even tested it in flour and they had a lot of mice problems after that. But it was probably a good test and probably gave them a lot of information that helped. Now, Boeing was also supposed to deliver a 1G trainer that was going to be used on Earth. There were a lot of delays. So the US Geological Survey, who was also involved in this, right? Makes sense. We don't have anyone in the US at that time who knows a lot about lunar geology, but we have some people who know about geology in general. So the USGS was involved and they created the Rover, which is the geologic rover. It was as close as they could get to what the lunar rover was going to look like in terms of control panel and how it's going to work, how you're going to get on and off of it, where everything's going to be packed. So they used this. It cost like $1,900. They bragged about that endlessly. They used this for training on the surface or on Earth, and they would train in New Mexico, Nevada, California. They went to the Hawaiian volcanoes and Flagstaff. I do want to briefly mention Flagstaff because there's still a site there that they created. They actually dynamited that looks, supposedly, I'm not a geologist, exactly like the Apollo landing site. Like they had created the Apollo landing site on Earth. And it is a historic site. If you go to Flagstaff, it's not actually Flagstaff, it's northeast of Flagstaff. Go to it, come back, report back, tell me what it's like, because I have not been there. But so just one of the many things they did to prepare, and that was to prepare for the Apollo 11 manned landing, but also they did a lot of lunar rover prep there. So here's the Apollo 15 team driving around in the Grover. And The Grover helped them learn the controls, like I said. It helped them learn how to spot and avoid craters. They practiced pulling their tools out. How are they going to pack their tools back up? You can't just throw everything in it. And then also gathering samples. But it also taught them how to work together on the rover. Who's going to drive? Who's going to navigate? All that good stuff. So they decided early on, Apollo 15 kind of decided this, and then the other missions followed suit, that the commander would drive, even though the controls were in the middle. So in case something happened, really anyone could drive. And the lunar module pilot did practice, but the commander would drive, the lunar module pilot would navigate and call out the things, you know, crater ahead, or, you know, whatever you call out. And then also the lunar module pilot took pictures. So it helped them work that out too, which seems kind of silly, but also you probably want that worked out before you go to the moon. And just here's another picture of them training. And the place near Flagstaff is called Cinder Lake. Report back. So this is all wonderful, but how are you going to get the rover to the moon? As I mentioned earlier, there was talk in the beginning, especially when it was going to be a pressurized vehicle and weigh a lot more, that they would send a separate rocket. Obviously, the cost of that was probably phenomenal. I can't even imagine what that was. So they decided that they would pack the LEM, or pack the rover into the lunar module, which is what they landed on the moon in. And I will read the description of how it's supposed to be deployed so I don't miss anything. So to deploy it from the lunar module, they use a system of pulleys and braked reels using ropes and cloth tapes. Oh, I did want to mention, it was essentially, not essentially, the deployment of the rover was as automatic as they could make it, because, you know, it's hard to work on the lunar surface anyway. So they would use the pulleys and the brake reels, and then the rover was folded and stored in quadrant 1 of the LEM with the underside of the chassis facing out. One astronaut would climb the ladder and release the rover, which would then be slowly tilted out, thank you, Lynn, by the second astronaut on the ground through the use of the reels and the tapes. The rear wheels folded out and locked into place. Once they were on the ground, the front of the rover could be unfolded. The wheels were deployed and the entire frame let down to the surface by pulleys. The rover components were locked into place, and the cabling pins and tripods would then be removed and the seats and the footrest raised up. And after switching on all the electronics, it was ready to go. So simplicity and automated as much as possible. And this is Apollo 15, the Apollo 15 astronauts checking out the rover. And here is a picture of it being the deployment test. So you can kind of see how it was folded. The lined areas are the underside. This is another deployment test. The cool thing about the tires is that they could be bent. They could be bent and folded really weird, and they would pop back out. I'm simplifying it, of course. History degree. And this is a picture of how it was packed in. So that's quadrant 1 of the lunar module. I'm dying to go point at it, so I'm going to. I need a pointer. I use it as a cat toy and now it's gone. And then there it is folded up. You can see it. Again, I'm going to go point at it because it's my show. So yeah, pretty crazy. Again, did I say already that one of the coolest things about the space program is that they were making it up? The other cool thing about the space program is that people actually believed all of this could happen. I would not be good for the space program because I'd be like, that will never work. You can't do that. Yes, you can. You fold it up and you send it to the moon. And then I just have some pictures that I wanted to show real quick before we get to the amazing samples that were brought back. So here's a picture that I chose because it's cool, but also you can see how the collection sample bags were packed into the back. Again, how it was packed up. It looks like my car does right now. Also how the astronauts were interacting with it. With the still picture, it's hard to see, but in those bulky spacesuits, it was so hard to do anything on the moon. Then just, there's other pictures where the LEM is really far away, which makes me feel like I can't breathe. I would never go to space. But pretty cool that they could finally explore further away from their landing site safely. As safe as you can get on the moon with a car that's never been driven before on that surface in a spacesuit, that if you don't have that spacesuit, you're going to die. They actually had, I forgot to mention this at the beginning, they had something they called the, oh, I'm blanking, Michelle and I talked about the buddy system, the buddy, anyway, on their rover was a buddy life support system. So if they were really far away and they had to, and the rover broke and they had to walk back, this system actually had special hoses so that the astronaut whose suit was not working could hook into the astronaut whose suit was working, and they could try to get back really fast in time. So redundancy was the key here. And this, I just like this because it's a color picture so you can see a little better. Here again, how the tools are all packed into the back of it. And then just, it's hard to see, but you can see the way he's kicking up the dust around his feet, kind of giving you an indication of what the surface was like. They were, you can look at pictures of the astronauts. Apollo 17 had some issues with their rover that I'm not going to necessarily get into, but because their fender broke, and Apollo 16 had some fender issues too, but they were absolutely filthy when they got back into the lunar module. There's some really great pictures of Gene Cernan just covered in moon dust. Oh yeah, this one I picked for the terrain, or the Lorraine, right? The lunar terrain. I didn't make that up. I Googled it though, it's not in the dictionary. Just so you can see the places that they were driving to and the hills and the craters, and oh my gosh, I would never go to the moon. But the rover made it able to explore these regions. Again, this is just to illustrate all the dust they were kicking up. This was a little test they did to see how, to show how fast it would go, and then they not cut donuts, but you got to test it out while it's up there, right? And then I just wanted to briefly mention, since I bragged about the science of these missions, some of the significant samples that came back. I was going to say in no particular order, but I think I did put them in mission order. So this is what the press dubbed the Genesis rock. It was brought back on Apollo 15, and it was called this because it was the oldest sample that had been brought back at that time. And it, the hope was that it would give clues to the early history of the moon, which it kind of did, but it wasn't exactly what they thought. I'm not a geologist, so you'll have to look that one up if you're into geology. But it still was a very significant piece that was brought back, and still, you know, very old, but not as old as they thought. Still very old. This is called the seatbelt basalt. And I chose this because I think the story behind it is funny. It was collected on Apollo 15, and it was called that because David Scott, one of the astronauts, saw this sample and he really wanted it, but they were running out of time. And, you know, if you listen to the transcripts or you listen to it, mission control is always telling them, you got to get back, you got to get back. And they're like, no, 30 more minutes, 30 more minutes. You got to get back, you got to get back. So he didn't think that they would let him stop to pick this up. So he lied on the moon and said he had a seatbelt issue. So this is the seatbelt basalt. I don't know that lying on the moon is worse, but he lied on the moon. This is called Big Muley. It's from Apollo 16. It is the largest sample returned from the moon. So we couldn't have gotten this without the rover. It's named after the field geology leader, Bill Muehlberger, who worked with them a lot. And I think that during the mission, he requested that they pick this sample up. And they had some sort of rule that they couldn't pick up a rock that was bigger than their fist or something. But he wanted this, so they grabbed it anyway. And then they named it after him. This is the orange soil from Apollo 17. It's essentially small beads of volcanic glass, which is pretty exciting to find on the moon. And I know this because we have the audio playing in our gallery. So every time I'm down in the Apollo gallery, you hear, look, orange, it's orange soil. So this was a very significant sample. Again, they were hoping that it would prove something about early volcanoes on the moon, and it didn't necessarily do that, but it was still very significant to be found. And then lastly, if only there was some place you could see a model of a rover, and it's right here. Reno County residents going to the museum for free. So are there any questions about the rover? Do we have online questions? Are we doing online questions? Oh, okay. I must have answered everything. Oh, not everything. Oh, the question was, what speed did it travel at? I think, and I'm going to tell you in miles per hour because I'm an American and that's how I drive. But I think it could top out. I think Apollo 17 got it up to 10 miles per hour, but they usually stayed around 6. Yes. Yes, it was. There's some fantastic videos. I couldn't even pick one. So check out YouTube, especially anything from NASA about them driving it, yeah, it's crazy. Yeah. Oh, the history of our rover. Our rover is not one that was built by Boeing. Our rover came from a movie. There we go. That's what it was. Space. Paramount, I believe. Paramount is technically our. Mm-hmm. Mm-hmm. Oh. Finders keepers. Yes, Roland. I'm sorry, what was the question? Roland, I love your questions. You always have the most imaginative questions. I would say not, just because of the exposure to solar radiation, the extreme temperatures. I mean, they did put materials on there that would last. Some of the tests of the rover that they ran, the materials would, like the tire is what I'm thinking of specifically. It would eventually break down, but it had, 250 miles on it. Well, then, in those extreme conditions that they had recreated in the lab. So, but they weren't going to drive that long. So I think they felt reasonably confident. So I'm going to say no. Final answer. Yes, sir. Oh man, I'm not going to be able to tell you the type of batteries, and they were not recharged. No, it was one and done. You use it and then you're done with it. So that is a good question. Oh, I'm so sorry. Yes, the question on that was what type of batteries and if they had to be recharged. And my final answer was, I can't tell you the type. You seem like if you're mechanically inclined, I'll say this to the group. It had a harmonic drive system. I read about it and read about it. I looked at Wikipedia and I decided, you know, I'm not in the realm where I can speak intelligently on it. But yes, sir. Mm-hmm. Mm-hmm. Oh, that's a good question. Yes. Okay. So the question was, we're talking about needing to know the terrain of the moon before you can build the proper tire for it. And what was that soil consistency? So it was in the places they had landed. It really was like 1 to 2 inches of fine powdery, uh, almost it clung to you. But then, yes, there was a hard crust underneath. Yeah, I mean, probably, right? Sand, flour, they tested all kinds of things. Yeah, but I would guess that would be why you choose flour. Plus, it sticks to everything like moon dust. Yes, sir. Oh, that's a good question. Was the rover used on several different missions? Each from Apollo 15 to Apollo 17. So Apollo 15, 16, 17, they each had their own. And then they left them on the moon. So there's 3 of our rovers on the moon. Yes. Is the one downstairs full size? I'm under the impression it is. Yes. It's an exact replica. Any other questions? Oh, you're letting me off you. Yes, do you have a question? Yes, yes. It was, there's a whole report you can read, but I mean, it was pretty weathered when it came back, just from the solar winds, the radiation, just the sun in general. So it was a metal piece, but it was weathered. Yes. Oh, that is a good question. Oh, I think that the surface of Mars is different, so they did not use the same type of tire. Um, I'm sure they learned a lot from our rovers, and there were a lot of unmanned rovers too. That you learn how they manipulate on the surface. I believe the Mars rover has many more tires than 4. It's not like a car. Yes, I think so. Yeah. Nuh-uh. All right. So, all right. Someone needs to fact check that. Okay. So I mean, it served a purpose. So the allegation here is that, I'm sorry, JPL is written in Morse code. Mhm. Is okay. All right. I did not know that. I know that when I would Google and try to find sources on rovers, I had to be very careful because I would get something about the Mars rover and be like, this is interesting. I've never heard this about the Lunar rover, because it's not the Lunar rover, it's the Mars rover. Any other questions? Yes. I would think so. I cannot imagine that NASA would not take that opportunity. The question was, after the mission, were we still able to watch the cameras? And yes, that's what I would say, until the battery. Yeah. Yes. geology question. What was the genesis rock made of? It starts with an A, anthracite, and Google that later. But it was significant. They were hoping to find it there, and the genesis rock was there. And I think in large samples too, like maybe they knew that there was some there. I don't want to say this was a complete shocker, but that it was significant because of the amount it had in it. One more time. A north-south. Thank you. Thank you. Volunteer hour for him. Any other questions? Yes. Mm-hmm. Right. Yeah, right. No, that's the cool thing about the space program to me too. We didn't know. The question was about contaminants, like how did we handle, because we were obviously concerned about contamination from the samples we brought back, from the suits that came back, all of that good stuff, which is real. I did not know that until I started working here. They quarantined the astronauts in the first couple of missions. I can't remember when they stopped doing it. I assume that there was a similar process for their suits. I don't know about that, but the samples were sealed when they came in. I think they were sealed in a vacuum too, to make sure they weren't exposed to Earth air. So the hope was to see the sample as it had been on the moon and study it here without it being exposed to air either. So there was a contamination concern both ways. But yes, there was concerns about that. This is the cool thing about the space program. We didn't know, is some weird bacteria going to come back and turns into a horrible sci-fi movie? I mean, we joke now, but I would have been. Anyway, yes. Yes. I think that's kind of where I broke this pencil. That's where a lot of our latest theories about the moon came from those samples, which is, yes, that the moon was originally part of the Earth and then also hit by something giant out in space. So the moon is the current theory, my understanding as of now still, unless something's changed in the past 3 years. I did a program on the moon a while ago, is that it's part of Earth, but part of space too. It's like a hybrid. Any other questions? All right. Well, thank you so much for coming. We hope to see you again in May, subject TBD, because I don't know yet.